bacterium exists on a petri dish, and every minute it has an equal chance to die, remain unchanged, divide into two, or divide into three. If we assume that every bacterium acts independently and identically, determine the probability that the entire bacterial colony will become extinct. So, to solve this problem, because we have a bunch of states transitioning to each other, it will be helpful to draw a tree. So at the starting state, it can either go into the death state with 1/4 chance, it can stay the same, which means remain at the start state, right, with 1/4 chance, or it could divide into two with 1/4 chance, or it could divide into three with 1/4 chance. So to solve this problem, we now need to find the probability that it dies. So by the law of total probability, the probability that it dies is going to be equal to the probability that it goes to the death branch multiplied by the probability that it dies given that it went to the death branch. And evaluating this, the probability that it traverses down the death branch is going to be 1/4. And the probability that it dies given that it went down this path is going to be 1, right? So this is going to be 1/4. We have this plus the probability that it goes down the same path times the probability that it dies given it went down this path. So going down this branch right here is going to be 1/4 chance. And the probability that it dies given that it went down the start branch is what? Well, P of D is defined to be the probability that it dies given we are at the current start state, right? That's why we're doing the law of total probability here. So that means the probability that it dies given it went down the same path is going to be just P of D by definition. So this becomes 1/4 times P of D. With this, we can continue. We can add this with the probability that it goes down the 2 path times the probability that it dies given it went down this path. So the probability that it goes down the 2 path is going to be 1/4, as we see in the tree right here. But what about the probability that it all dies given it went down this path? Well, if it went down this path, what we have now is we have 2 colonies, each at the starting state, right? And we want for both of these colonies to die. And P of D is defined to be the probability that the colony dies given that it's at the starting state. So the probability that the first colony dies is P of D. The probability that the second colony dies is also P of D. Therefore, for them to both die, it must be P of D squared. So therefore, this becomes 1/4 P over D squared. And now by the same logic, except for 3 colonies now, is the probability of 3 times the probability that it dies given it went down this path. So the probability of going down this path is simply 1/4. And this path is simply going to be the 3 colonies starting at the start state, each with P of D chance to die. So therefore, that's P of D to the 3rd. With that, that's 1/4 P of D to the 3rd. So we sum all this up and we should get our answer. And for the sake of simplicity, let's say P of D is equal to x. Then what this becomes is x is equal to 1/4 plus 1/4 x plus 1/4 x squared plus 1/4 x to the 3rd. And what can we do about multiplying 4 on both sides? We get 4x is equal to 1 plus x squared plus x to the 3rd. Now this is a sum of a geometric sequence because to get to every next element, right, it's going to be multiplied by x. So how do we find the sum of a geometric sequence? Well, we can derive it from scratch. To illustrate, if you're in a problem-solving scenario and you forgot it, you can just do it just from the logic of how to find the sum. The sum of a geometric sequence is, by definition, the first term plus the first term times some common difference plus the first term times the common difference squared plus the first term times the common difference to the 3rd. We only have 4 terms, so stop at the 4th term. If we multiply q on both sides, that becomes a1q plus a1q squared plus a1q to the 3rd, right, plus a1q to the 4th. If we subtract qs with s, then this pair cancels out, this pair cancels out, and this pair cancels out, leaving us with a1q to the 4th minus a1. If we factor out a1 and s times q minus 1 is a1 q to the 4th minus 1. S is therefore equal to a1 q to the 4th minus 1 divided by q minus 1. We can now plug in the appropriate variables for each value. But first, let's simplify. This is a1 q squared plus 1 times q minus 1 q plus 1. right, divided by q minus 1. So q minus 1 cancels, and we're left with a1 q squared plus 1 times q plus 1. What is a1? Well, a1 is the first term, which is 1, times q squared plus 1. Q is x, and q is also x, so x plus 1. That is equal to the sum of x, or 4x rather, right? Just from what we have in our original expression. So now let's solve for x. So first expand out, so x to the third plus x squared plus x plus 1 is equal to 4x. Hence, x to the third plus x squared minus 3x plus 1 is equal to 0. For this kind of expression, potential roots are multiples of 1. So it could be minus 1 times minus 1 or 1 times 1. So potential candidates are minus 1 or 1. Let's test positive 1 first. 1 plus 1 minus 3 plus 1, well, that's 0. So x minus 1 is going to be a root. So therefore, let's simplify. We can put x squared here, and 2x squared minus 3x, so just to illustrate what I'm doing, we have this expression, and we divide it by x minus 1. Put x squared here, x to the third minus x squared. Subtract, so 2x squared minus 3x. Put 2x. So that becomes 2x squared minus 2x. And that becomes minus plus minus minus x plus 1, so just minus 1. So therefore, this becomes x squared plus 2x minus 1, which is equal to 0. And sorry for the messy handwriting here, but that's what our expression comes down to. So therefore, x can either equal 1 or something else. But we know that our answer is in the form of root a minus b. So it has to be solving this expression here, x squared plus 2x minus 1. So if we solve that and we put some, and we create some room, we can kind of delete this, right? So we need to solve x squared plus 2x minus 1, minus 1 is equal to 0. So by the quadratic formula, 2 minus 2 plus minus the square root of 4 plus 4. So that's minus 2 plus minus root 8 divided by 2. That's minus 1 plus minus 2 root 2 divided by 2. That's minus 1 plus minus root 2. Our answer is in the form of root a minus b. So therefore, this is going to be root 2 minus 1. Hence, a is 2, b is 1, and a plus b is equal to 3. So that's your final answer.